This is the folder that I have shared with you. So this is the dataset folder, the dataset that you have provided with me. These are images folder that contains some of the background images for the UI. This camera IP.text is automatically generated. Zero means it will take my webcam as an input. Okay. Then
Okay.
this is the database.csv, which contains all the description, name of the plant and disease. Then we have this train model. This is the training file. This is the testing file, and this is the main file. Starting with the training file. So first of all, I have imported libraries, that is NumPy, Pandas, Torch. Now, from Torch, in Torch, I am loading my dataset and I am resizing my dataset to 255 uh, dimension. I'm loading
Like,
my
why
data
are you using the torch?
uh, because like uh, training the model seems much more efficient to me in this. There are different
Can't
libraries
we
we can
use any other models like some other?
use. Apart from Torch, we can use TensorFlow, but that would also do the same thing. But the issue that came to me was when I was training the model using TensorFlow. I don't know why the loss was getting very high and the accuracy was getting very deprived. So Torch was giving me better accuracy in this case, in this particular project. That is why I use Torch.
What about ResNet?
ResNet, ResNet. Currently here, I use just CNN. So
Basically, in CNN, like what you have used, because they have asked the question to us in our presentation, like what you're doing in CNN, like which layers are you using, and how those images are you get to detect, like it is used to take in black and white, or how does it get segmentation, like those kind of question was came to us during the presentation, so I wanted to know about that also.
initially, what we are doing, we are transforming the image to a particular size that is 255, and the center crop is 224. So we are cropping the image and resizing that. Why we are
Okay.
doing that? Because we want a type of similarity between all the images. Because dimension might differ in the different images. Some of the images could be very high, some of the images could be very low. So we don't want that. Then when once we are done with that, we are splitting our data set, and this is the training, testing, and validation size.
Okay.
Okay.
Sir, another one member is waiting in the waiting boxes. Can I just join her?
Okay. Then we, we are creating our model here. So as you can see, we are using simple sequential model from CNN here. We are not using ResNet or anything. We are using simple CNN model where we have created different layers like ReLU, batch transform, and batch norm 2D, max pool. These different layers we have added, and then we have added multiple layers of the same sublayer.
Can you say some more detail about layers, because they are focusing more about layers in our CNN?
Uh, you can just check on the internet once ki what is this ReLU bash norm, because like these are very theoretical concepts. Right? So you can check it
No,
once, or
like
I will share.
how
Yeah, I
this
will
is
share.
useful in our project, like that I want you just give small description, this how it is useful to our project. I'll check more detail about that in internet.
Because like CNN is the most preferred algorithm when it comes to image classification. That is what we are doing here. We have different
Yeah.
images and we are classifying those.
Yes.
That is
Yes.
why we have gone for CNN here. Okay. Now, once we have created our model, we are checking if we have CPU available or GPU available. In my system, I had GPU, so it have selected GPU as a default device for training the model. Now, what we are doing, we are just summarizing the model. So these are all the layers in my model. Yes,
These are the
and
CNN layers,
these are
huh?
all the layers in my yeah. These are all CNN layers.
These are the layers which we are using.
Yes. So in
Okay.
total there are 22 layers in this.
Okay. Okay. Okay.
We are incorporating so here only we are training our model. So what we are doing, we are loading our model. We created that model. What is the criteria? So this batch GD is called here. So what is the criteria? Criteria we have defined here. So it is like cross entropy. Then what train loader? What is train loader? Train loader is basically like what is my training data? I have loaded that. Batch size I kept as 64. This is test loader and this is validation loader. What is the number of epochs that will be there? So we have defined all the things. Then for each iteration of the epoch, we are just running a loop where we are calling our model, we are applying the loss criteria, and then we are training our model for the particular epochs that are. So after training, as you can see, initial loss was 17.513, then it gone down to 6.277, then 4.272. Then initially, we have very less loss. Then we saved our model. Now, once our model is saved, I created this spread.py. Now, what this spread.py is doing, it is simply now again here I have declared my model. So the same thing that was there, I have declared here, and required libraries we have imported. We have created the classes that are there. So in total, we have like 22 classes here. Then model is we have defined our model. Why we have defined our model? So that we can load the pre-trained model that we have created here. So
Excuse. Uh, you are only giving the data set which I have provided.
yes,
What about if I scan some any other plant?
uh, see, because in that case, what is happening? We are getting very less accuracy in that. So, for example, if you have scanned any other plant, then you will get a very less accuracy. So we have kept a threshold value. If the threshold value is greater, then only we are saying it is a. I will show you in the main file that is there in the main file. Okay.
But you're provided only the 22, no? What if I give some any other plant? You have the data set is provided only for that. How will it detect for any other plant?
Uh, it will only detect these 22. But if you add anything else, then what will happen? So, for example, it is detecting aloe vera as let's say 99% accuracy. But if you upload any other image, let's say you upload a tomato leaf, then accuracy is going down very much. So it is saying it is 20% looks like aloe vera. So what is happening? We are keeping a threshold value here. As per that threshold value only, we are allowing that these this should be the prediction.
No, actually, my question is you're not training the data set itself for any some other plant. How will it predict? It is my question. Without your training the model, how will it detect? okay, it's low accuracy, I understood. But without you training that particular plant, how will it detect? How you come to know that it will give 20% of accuracy?
See, I can add means I have no issue to add one other folder and dump in different plant images there, different random plant images there. But in that case, what will happen? As you can see, uh, some of your folders have only one image, like this. Now this have only one image. What will happen if I create other folder? In that case, I would need to dump for 50, 60 different types of plant. Then model with this model, this data is not homogeneous, and it will create kind of overfitting because we have a folder with the higher number of images. So it will create a overfitting here. If
Okay.
you see, that is not any big issue here. We can just anytime create a new other folder and dump in bunch of the random plant images, and just retrain our model. है ना?
No, if suddenly if our faculty they ask some other plants except these plants, if they suddenly ask to scan us some other plant, no. So I just ask you, like
In
what
that case,
happened on
in
in that
that
case?
case, see, if you want to add or detect any other plant, so like apart from all these, you want to detect like ashwagandha. So
Yeah.
you would need to create one folder for ashwagandha. You would need to train. You would need to put the images. Then you would need to go to this training file. In this training file, what you would need to do, no, in this training file, you don't need to do anything. But in this spread.py file, you need to change the number of classes because the number of classes will increase. It will go down to 20, go up to 23, right? You will need to update here as well in indexes to class, and you will need to update in that database.csv file. These are the folders that these are the fields that you need to update in order to train for a new plant.
Sir, can I just show how to add?
No, I got it. I got it. Leave. Sir, like my question is, now if suddenly if the ask means it will not detect at all, or at least it will show this is the plant like that.
Uh,
If for example, if they are asked to scan some like example tomato, they told us to scan this tomato, but it's not in the data set. So then will this will it will detect? Okay, it's low accuracy. Will it detect at least?
uh, in the most of the cases which I have tested, it is always giving me like no means no such plant is there. So it is what it is giving me. I'll show you. Means in main.py file I have kept it. So in main.py file, there is one version issue here. I'll update the code. So in this, what we are doing, we are checking with accuracy. If accuracy is less than equals to uh, 40, then we are saying that R that is the description is like null. DS is equals to null, and again the name of the plant name. So this will pop up. So it will give you not a medicinal plant if we are giving any if we are detecting any less accurate. Okay. So coming back here, what we are doing, we are loading our model, and in this prediction folder, we are uh, opening the image that which we have clicked. Then we are again resizing and transforming the image as per our requirement, as per we have trained it. So it is not black and white image; it is always a RGB image here. Then we are loading our model and we are predicting the output. So as per the prediction, I am checking like what is the title, what is the name of the plant, and what is the prediction accuracy. These are the two things that I am returning here. Coming to this, first of all, we are loading the database file. Then we are importing all the required libraries, and we are creating a tkinter window for our interface. And uh, this is the option. We'll come back to it later. So we have two buttons here. First, using first button, you can add your camera IP. Using second button, you can start the detection. Now, what is happening in camera IP? So it is another tkinter window where you are asked to enter the camera IP for plant detection. In the most important thing here is here that how you can detect it from mobile phone. So if you are using Android phone, then there is a application named IP Cam in Android. So once you open this thing, once you load this, once you download this, you will get an IP address here. This here you will get one IP address. That IP address you would need to paste it in that text box. Okay, this
Which
is the
text
main
box?
means here only where when we are asking like to enter the camera ID for the plant. Okay,
When we
this
are
is
detecting on the during that time we need to give.
yes. If you want to detect from mobile phone. Okay,
Okay.
then this is if you are using Android. If you are using iPhone, then we have an application named IVCam. So you need to download it both in your laptop as well as in your system. And if both of them are connected through the same Wi-Fi, it will automatically connect, and you would need to just enter zero here. So zero is by default the webcam. This application converts your iPhone camera into webcam. Okay, so this is how you select and put in the camera IP. Now, once you have provided with the camera IP, we are loading the camera. We are asking user to press C in order to click the image. Once user press C, we capture that image and we save that image. Then we load our model. So we are calling this prediction function that we created in that pred file. From there, we are getting the name and the accuracy. Thus, we are calculating the disease name, description, and everything we are fetching from the database file, and everything we are rendering as an output and showing it into this tkinter window. Okay, this is what is happening here. Any doubts?
Sir, actually, what I thought is like you asked for some more plans. No, I thought that you are asking for these particular plans which I give for that it will be very high accuracy, and I thought that you will add some more data set. I thought like that but you have not done that. You have given only the data set and also the description for only that much of plants. So
Yes,
like
see,
I'm a bit scared if they ask to scan some other plants, what to do. Like if it's a medicinal plant and then it will give it is not a medicinal plant, then whole project will be destroyed. No.
in most of the cases, this is not happening. And database for plants I did not have had. And in this, you can add as much data as you want and retrain the model anytime.
Sir, you can show how to retrain the model.
Uh, I've already explained that. You just need to add the folder here. Then you need to change the values in this spread.py file,
Sir,
and
I'm
you need
asking how, sir, example, you had any one plant and show how to change.
you just need to run this file, this whole file, this training.ipnb file. You just need to run it after you have added the folder. It will create, uh, it will update this plan.pt file. Then what you can do, you can just simply change the value in pred.py file. You can change the value here in index file, and you can increment the number to 22 to 23 or whatever the number of folders that you are adding, and you just need to change the values in database.cs file. That is all the major changes you need to do. Nothing much is there.
Sir, and when you're scanning the image, no, like how it is used to detect that, like what the process of that detecting and classifying, how on what basis will it classify? Like uh, our faculty talked about segmentation and all those kind of words. I really didn't get. Have we used that like will it detect using the black and white or any colored image? They ask this question. How will these images will be scanned? While
Uh,
scanning, it will be take the black and white or colored images.
we are taking colored image here. We are resizing that image, and we are classifying that image. Classification and segmentations are two different things. We are not implementing segmentation here. We are implementing classification here. So
Okay.
we have already trained our model. That model is saved. Once we have loaded our model, we will pass this new transformed image to the model, and based on this, we will get the prediction output.
Okay. Okay. Sir, and as you said, can you explain like what is the pre-processing apply like images before you feeding them into the CNN?
Already, like we are cropping the image and we are resizing the image. That is what we are doing here. That- This is the only thing we are doing here, pre-processing.
Like before feeding them into CNN,
Yes.
you're cropping and you're resizing it.
Yes.
Yes, okay. And sir, and why it is suitable for this image classification? Sir, like why CNN is best for the image classification?
This is because I don't have a particular answer that why it is best, but through all the research and everything, these are there are different algorithms. CNN is most used everywhere in the industry for the classification.
Okay. And which is the deep learning framework and libraries you're using here? Please, can you tell that once again?
Torch and Torch Vision are the only libraries that we are using for.
This is a
Uh,
framework. Is the torch is a framework?
it is not a framework; it is a library.
It is a library.
Framework would be like YOLO or something because frameworks are already built. So we always build on top of the framework, because it just gives you a structure, and we add in some of our input to that structure. That is what we do in the framework. But there is no framework here. We have created our own model. We have defined all the names here, and then we have trained our model.
Mm, like this resonate and another one what you told that which TensorFlow.
Hmm.
Yeah, these torch all are same.
Uh,
All are, they all perform the same function.
Thought and TensorFlow. These are the libraries used for machine learning or neural network implementation in Python. ResNet is an algorithm based on top of CNN. It is like a framework only.
Okay, okay,
ResNet is a framework.
okay, okay. It is a library, right? Okay.
No, that is not a library. That
No,
is a
no, this
model.
torch.
Yes, Torch is a library.
Yes, okay. One request. Please, can you add some more plants and you give it?
Uh, Honestly, if I had any data set, or if I would have found any data set, I would have definitely added that. But I don't have any data set.
Sir,
I-
it is there in some website. No, sir.
if you find it, just send me the link. I will definitely add that. I don't have any issue.
I've sent you on that day only. I've sent some link in from Kagle something, that website name.
I don't. I did not find that. Use just if you have, you can share it to. Okay.
आपको
Just
मैंने आपको मैंने ऑलरेडी भेज रखे ना दो तीन जो इन्होंने भेजे हो।
तो ऐसी कोई लिंक है नहीं डेटा सेट की। एक
क्या
बार ये
बोल रहे
दोबारा
हो?
दोबारा पिन करना यार।
क्या बोल रहे हो? आवाज अच्छा पिंग करो।
हाँ।
देखो।
ये तो डेटा सेट इन्होंने भेजा है, ये तो इंक्लूड कर दिया है मैंने।
हाँ तो वही तो है।
Yes, you have only sent us the zip file, not any other link.
No, not zip file. I've sent the link in the very beginning. Before this, in the very beginning, I have sent.
कोई लिंक
कैन
भेजिएगा भाई।
जस्ट पिंग कैन जस्ट पिंग दैट लिंक।
Wait, just a minute. I'll see. This one, you have only sent. No, you told that this is the data set I'm using.
So this was the data set I was about to use, but then said you don't want it for leaves. These are leaf images. These are not plant images. You only stopped me from using this data set.
If we put this data set means we can't detect.
You can detect leaf only in this case.
Okay,
This is,
means can only leave then for those
yeah.
particular plants. It's no problem.
But earlier only you said you don't want to scan the leaf. You want to scan
But
the whole plant.
I have the major plants. For that I can scan the entire plant. No, that's enough. I'm just in case if they ask for that purpose, I'm only asking.
See, if I include this with your data set, then your data set will not work at all, because First of all, there are the few images, and
We
this
will
is
add if we want some plants, or else if we want some more plants, we'll send the zip file. You add and give us.
definitely we'll
Okay
do
then.
that.
Thank you friends for watching my video. If you are new, then subscribe channel and share with your friend. Thank you.